Hi, this is Polly Schultz. Today we're going to be examining a bacterium responsible for Lyme disease, Borrelia burdorfei, and using this to illustrate some of the nomenclature we'll be using in the class. Borrelia burdorfei is a pathogen that's a spirochete. You'll notice in the slide here it has a corkscrew-like shape, and the axil filament then goes the length of the bacterium and is located between the outer cell membrane of the cell wall and in the periplasmic space of the bacterium. We're going to examine the vector that transmits Borrelia burdorfei, examine why we call it an emerging disease, and look at some of the factors that increase the emergence of this disease and how it causes disease. First, I'd like to introduce the nomenclature that we use in microbiology for all bacteria. It's a binomial nomenclature. By that, I mean you list the genus and species. Typically, the genus name is capitalized and the species name is kept in lowercase. The name can either be shown in italics, as our example here, or underlined as in our other example here on the screen. Borrelia burdorfei causes Lyme disease, as I mentioned earlier, and I'm going to go over a brief timeline of the identification of the disease here in the United States and why we call it an emerging disease. The disease itself was first identified in 1883, although we know now that even Otzi the Iceman, a frozen 5,000-year-old human found in the Upper Alps near Spain, had Lyme disease at the time of his death, so it wasn't a new disease to Europe. In 1909, a researcher presented evidence that it was associated with what we identify now as we call the bullseye lesion on the skin, often seen right after the person has contacted the disease. In 1929, another researcher speculated that the origin of the disease was through the biting of a tick and connected the disease with joint problems. Later, the disease was also identified as being associated with neurological problems and psychiatric problems as well. Many of you may know of someone who actually has the disease and may have suffered joint pain, arthritic type joint pain from the disease. As you'll see in this picture of the United States, most incidents of Lyme disease, at least reported at the CDC up through 2008, show that it's most prevalent in the eastern part of the United States. It was originally named after Lyme, Connecticut, where it was first identified. The disease has now throughout the United States, and you can see it's rather high in the state of California. We do have cases here in Oregon as well. Lyme disease works by the bacterium, Borrelia burdorfei, being transmitted by a tick that bites the person. As you'll see, there's the picture of the tick in there. And as the tick bites the person, it transmits the spirochete in its saliva into the human that it bit. You also often find Lyme disease then associated with things like going out and hiking, and especially in areas of the country where it's dry. So the tick is transmitted often as ticks transmitted by deer, and from there the ticks find their way onto a hiker individual such as this hiker in the particular picture. There is medication that has been approved as a vaccine on the market, but it was then removed. And so currently we don't have a vaccine. As you'll see from this chart, the bullseye and rash associated with is seen in about 68% of cases, where things like arthritis, facial palsy, and meningitis are at much lower rates. But all these can result from being bit by a tick carrying Borrelia burdorfei bacteria. As I mentioned earlier, the bacterium is a spirochete, meaning it has an axial filament through the whole length of the organism, and is an example. Then you can see the filament between the outer membrane and the inner membrane in the periplasmic space. Lyme disease is called an emerging disease because it's actually increasing in the number of cases throughout the country, and it's what makes something an emerging disease. It has to be increasing in the country where you're talking about it, and it's again transmitted by a tick, specifically the black-leg ticks. Some examples of some different types of ticks. The incidence of Lyme disease has remained about steady over the last 10 years, varying often with how dry it is, so the incidence of ticks, exposure by individuals, and migration of deer populations, which often carry the ticks. Over 22,000 cases reported by this in the CDC in 2012. This emergence again is often not only due to just increased surveillance, so we have better reporting schemes, but as more people move from the cities out into rural environment and become in more close proximity to ticks, that ups the probability of them being bit by a tick. So if you go hiking or out in the areas where ticks are common, you should definitely check yourself and make sure that you don't have any ticks on your body, and especially for children out playing in the dirt and out hiking. Forest fragmentation, increased deer population movements allow the ticks to move from one population of a deer to another, and they have crossed the entire United States. Pathogenesis. The definition of this is the development of a disease, the origin of the disease, and the chain of events leading to the disease. The pathogenesis then for Lyme disease is that it's a disease carried by a bacterium, specifically Borrelia burdorfei, and it shows a correlation between the visible sites of this bacterium, the infection, and the symptoms that we describe later. For Lyme disease, many of the symptoms that you see later, or we're going to look at, are associated with a autoimmune response, and that's why you see a large variation in the response from individuals once they have been exposed to Lyme disease. So how does it cause disease? Specific surface proteins that are able to fool the immune system, if you will, by binding to it and associating with collagen. And this produces a situation where the immune system sees human collagen associated now with specific proteins that are foreign from the bacterium. This itself often elicits an immune response. In individuals that have been exposed to Borrelia burdorfei, we often find antibodies, and these antibodies then cross-react with neural tissue antigens in the brain, spinal cord, and dorsal ganglia. So what we have is a situation where the proteins of the bacterium associated with the proteins of the person have been able to elicit an autoimmune response where antibodies may then be cross-reacting, meaning attacking your own tissues. Enjoyed this overview of an emerging disease and been able to see how some of the things that we're going to be doing in class and lab as far as labeling different bacteria, identifying their shape, apply to this particular organism, the bacterium Borrelia burgdorferi. Have a nice evening.